Hi everyone, in today's lesson I'm going to teach you how to solve limits algebraically that involve conjugates. So as always with limits with algebraically, we're always going to try direct substitution first. If your answer is a real number, then we know that that's our answer. And we know that if our answer is 0 over 0, that means that there is a hole in the graph. Today we're going to talk about another technique that can get rid of the hole, which is a conjugate. And then as always, we'll plug back into our equation for our final answer. So I have a visual representation, obviously here where there's a hole in the graph. And I want to find the limit as x approaches 16. So we could see that the limit as x approaches 16 from the left and the right is equal, and it's approximately in between 0.1 and 0.2. So let's try the steps that we've learned. First step is direct substitution. So let's plug in 16. So the square root of 16 minus 4 over 16 minus 16. Well, I know the square root of 16 is 4, so 4 minus 4 is 0, and 16 minus 0 is also 0. So this proves that we do in fact have a hole in the graph at that value. So now instead of using factoring to dig ourselves out of this hole, we're going to use a concept called conjugates. And conjugates allows us to simplify the equation. So let's rewrite it first and I'll explain how it works. So what a conjugate is very similar to dots. And I'm going to do this on the side and then I'll apply it to the radical. So let's just say I have x squared minus 25. We all know that we could factor that by dots by x plus 5 and x minus 5. Now, what we don't often tell you is that this x plus 5 and x minus 5 are what we call conjugate pairs. And all that conjugate pairs are is two terms that are separated by a plus and then a minus. So in this case, we have a radical x and a minus 4. Now, we're going to take the conjugate of the radical pair. So if I had x plus 5, x minus 5, the conjugate of rad x minus 4 is just rad x plus 4. And what this process does, it allows us to simplify this equation. So what we're going to do is we're going to multiply the top and the bottom by the conjugate of the radical. So rad x plus 4, rad x plus 4. And this will give us our simplification. So let's double distribute out this and simplify. So rad x times rad x. We know that a radical times a radical is x squared, goes on the inside, right? Inside times inside goes here. Rad x times 4 is just 4 radical x. And negative 4 times rad x is negative 4 radical x. And negative 4 times positive 4 is a negative 16. Couple things will simplify. These are like terms that will cancel. We know that the square root of x squared is just x. So we've got x minus 16. So what I did was I simplified the numerator, and a good trick is what we can do with this denominator. Wherever the non-conjugate pair is, we actually can just leave it. So if we leave the denominator as x minus 16 and rad x plus 4, we actually never have to do any double distributing for this piece, because watch what happens. See these x minus 16s? They cancel, and 1 would be left over on top. So my simplified form of all of this is 1 over rad x plus 4. So just to recap that, we multiplied the top and bottom by the conjugate of wherever the radical was. So radical x minus 4, we multiply by rad x plus 4. We double distributed out only the stuff in the numerator because that's where the radical was. So this piece we double distribute. And this piece we leave alone. Okay, so we double distributed the numerator and we simplified it to x minus 16, and we factored out that x minus 16 to 1, and now this is my simplified equation. So now that we have a simplified equation, step 3 is always to plug back in. So we're going to plug it back in to this. And now we're going to plug in 16. So 1 over the square root of 16 plus 4. We know the square root of 16 is 4, and 4 plus 4 is 8. So 1/8 is approximately 0.125. So that, or 1/8, is between 0.1 and 0.2. So the limit from the left equals the limit from the right. All right, let's move on to the next example. All right, so in this one, I want to find the limit as x approaches 1. We can clearly see from the graph that the limit from the left and the limit from the right are both approaching 4, so we know the answer should be 4. But on an exam, you're not going to have the graph. We need to be able to know how to do this algebraically. So again, step 1 is direct substitution. So let's do that together. We're going to plug in 1. So 1 minus 1 over the square root of 1 plus 3 minus 2. 1 minus 1 is 0. Radical 1 plus 3 is radical 4 minus 2. Square root of 4 is 2. So 2 minus 2 is 0. So got our 0 over 0, which is our whole. So now we're going to use not factoring, but conjugates. So we have x minus 1 over radical x plus 3 minus 2. So notice with this problem, the radical is now on the bottom instead of the top. So our radical is the thing that we're going to conjugate. So we're going to multiply the top and the bottom by the conjugate now of the denominator, where these radicals are. So remember, conjugate means to switch the middle sign only. The middle sign. So we're going to make this radical x plus 3 plus 2. Notice that I'm not changing this plus. This is one term, this is the other. I'm just changing the sign in the middle. So radical x plus 3 under the radical plus 2. Now, if we write down the process, we're going to now leave the top alone, and we're going to double distribute the bottom. Why? Because we're double distributing where the conjugate pair is, and we're leaving alone the other piece. So I am going to rewrite the top, x minus 1 times radical x plus 3 plus 2. And now let's double distribute that bottom. So the first piece will be radical x plus 3 times radical x plus 3. So this one, you kind of have to know something about radicals. So let's just say I gave you rad 5 times rad 5. We know that that's rad 25, which will reduce to 5. If I gave you rad 10 times rad 10, we know that that's rad 100, which reduces to 10. If I gave you rad x times rad x, we know that that's rad x squared, which reduces to x. So if we follow the same pattern, I multiply a radical by itself, it becomes back one of the things under the radicals. So if we did that with rad x plus 3 times rad x plus 3, I don't need to know what this is. All I need to know is that it will come out to x plus 3. So a radical times itself is the same thing as squaring it, x plus 3 squared. Remember, when you square a radical, the square and the square root cancel each other out, and you're left with that x plus 3. So when I do that first piece over here, this one times this one, I get x plus 3. Now, when I keep going and I do rad x plus 3 times 2, I'm going to get 2 rad x plus 3. And then this one, negative 2 times rad x plus 3. And then this last one, negative 2 times positive 2, is negative 4. So you'll notice these two middle terms cancel. Now think about that. Will that always be the case when you're multiplying by conjugate? Absolutely, right? The negative and the positive will always cancel each other out. So if we simplify this, x plus 3 minus 4, 3 minus 4 is negative 1. So my x minus 1 on top with my rad x plus 3 plus 2 all over x minus 1. I added the 3 and the negative 4. Now look what happens. The x minus 1's cancel, and I'm left with just this rad x plus 3 plus 2. This is my simplified equation that I'm going to now plug into. So my step 3 is to plug back in. So we're going to plug in the x value of 1. So radical 1 plus 3 plus 2. 1 plus 3 is 4, and square root of 4 is 2. 2 plus 2 is in fact 4, which is the answer that we saw graphically. All right, that's it for today. Now's a good time to jot some things down if you have questions, and we'll see you in class tomorrow. Have a good night.